My house in Budapest, my hidden treasure chest, golden grand piano, my beauty focus.
I hope that you understood this topic. It's pretty easy. It's called piecewise defined function. And if someone didn't understand, join me at 4 o'clock at the basketball court so I can explain you better. Thank you. Okay guys, thank you for coming. In this evening I will show you another way to understand the piecewise defined functions. Remember, for this topic you will need to know how to get domain, rank, and also you need to know the specific forms of the different functions. One of the things that you need to remember is that if you have an x squared, if it is positive it's going to be this way, and if it is negative it's going to be this way. Now if you have a cubic x, if it is positive it's going to be this way but in a form of an s, and if it is negative it's going to be to the other way but always in a form of an s. If you have an absolute value, you have to remember that if it is positive, it's going to be this way, in a form of a v, and if it is negative, it's going to be to the other way. Well, for a better explanation to understand this topic, imagine that this is our Cartesian plane, okay? This is going to be obviously our x-axis, and this is going to be the y-axis. Well, now imagine that I give you this function, that is f of x plus 5, if x is greater or equal than 1. And the other function is x squared if x is lower than 1. The next step is that you have to substitute this value on the x, always on the x. And most of the times, this value is going to be the same in the two functions. Next step is that you have to do the operation and then get the coordinates. For example, in this first function is 1, 6, because I substituted the 1 into the x and then I added 5 and it's 6. So the coordinates are 1, 6 because the x is 1 and the y is 6. In the second function is 1, 1 because 1 to the square is 1, so it's equal, is 1, 1. Now we're going to graph these functions on our Cartesian plane. Now you have to remember that always this number, this value, is always going to be the asymptote in the y-axis. So for example, in here is 1, so here's my asymptote. It's in the x-axis. Now we have to draw the functions using the coordinates. For example, in here 1 is 1, 6, and it's included. This symbol, if it have an equal in here, is because it includes, and we're going to use this type of ball if it includes, okay? And here's 1, 6. So I go into my x-axis, 1, 6. 1, 2, 3, 4, 5, 6. And this ball, I'm going to use for the ones that are not included, like this, for example. And I'm going to use my coordinates to use the point, and it's 1, 1. So again, I go into my x-axis, here is 1, and the y is in here, 1, 1. So now I'm going to represent the first function. Like it's an x alone, you have to remember that an x alone is a diagonal. So the coordinates for our first function are 1, 6, and it's an x alone. And like it is positive, it's going to be a diagonal on this point, like this. So our first function that was 1, 6, it is like this. The coordinates to our second function are 1, 1, and like it's a x squared, it's going to be a parabola. So it's positive, so it's going to be like this. So for these two functions, our whole graph will be like this. So our last step is pretty easy. You have to get the domain and the range of our graph. What is the domain? The domain is all the possible values that you can have in the x-axis, and the range is all the possible values that you can have in the y-axis. Our domain for our graph is to minus infinity to plus infinity, because you can have all the values that you want in the x-axis. And the range is you're going to start in 0, including it to plus infinity. Why not minus infinity? Because in here you don't have any other value. You start from the 0 and you have to include it. We're going to have another example. Imagine I give you these two functions that are minus x squared if x is greater or equal than 0, and the second function is x minus 2 if x is lower than 0. So by this time you should know that these two values, that in this case are 0, are the value of the vertical asymptote. So I already solved the operation to get the coordinates of the two functions. For the first one is 0, 0 because I substituted the 0 in the x, so it's equal to 0. And in the second function I did the same thing. I substituted the 0 in the equation, so it's equal to -2. So the second coordinate of the second function is 0, -2. Here is our Cartesian plane. As you can see, I used these rulers to represent the vertical asymptote, and as you can see, it is the same at the y-axis because our value was 0. So our first point is 0, 0, so it's going to be in the center, and I'm going to put this ball because it includes it. And the second point is 0, -2, so I'm going to put it right here. And I put this ball because it is not included. So our first function is a minus x squared, and it is negative. So it's a parabola, but to the negative side. So it's going to be like this. So this is the graph for our first function, that is minus x squared. So our second function is a x. An x alone, do you remember that an x alone is just a diagonal? So I'm going to place it here on the point. So here we have our two final functions and its graph. So our last step, the domain of this function is going to be to -infinity to +infinity, because as you can see, you can take any value. And the range is going to start to -infinity to 0, including it. You cannot take any value in here, in the positive infinity, because you don't have any value.